Iniciamos con la primera plática plenaria de Data Science for Wind Energy. El doctor Milton de Georgia Institute of Technology en los Estados Unidos. Voy a dar su pequeña introducción. Doctor Dean, ¿estás ahí? Dr. Dean is the Anderson Interface Chair and Professor in the Milton Stewart School of Industrial and Systems Engineering at Georgia Tech. Prior to joining Georgia Tech, he was the Mike and Sugar Barnes Professor of Industrial and Systems Engineering at Texas A&M University. Dr. Dean's research focuses on data and quality science and system informatics. He is the author of the CRC Prize book, Data Science for Wind Energy, and a co-author of the Springer Nature book, Data Science for Nano Image Analysis. His research work is recognized by many awards from the IISE, the Industrial Institute's Industrial and System Engineering. Such like 2019 IISE's Technical Innovation Award 2022, Informs Impact Prize 2024, ASME's Blackboard Machine Tool and Gauge Award 2024, SME's SMO Research Implementation Award, and 2024 AISE Energy System Division's Career Achievement Award. Dr. Dean is Senior Vice President of the IISE on International Operations, and he is also the Editor-in-Chief of the Informs Journal on Data Science. Dr. Dean served as Program Chair for the IEEE CASE is the Conference on Automation Science and Engineering 2025, just was held in Los Angeles in August this year, and the Editor-in-Chief of the IISE Transactions for the term 2021 to 2024. Let's welcome Dr. Dean to share with us his book, Data Science and Wind Energy. Sorry. So please, Dr. Dean, you can share your screen.
Okay, Dr. Lee, can you see my screen?
Yes,
can
we
you
can.
Hear me?
Yes, we can.
Is this a full screen mode?
Yes.
Okay. So you can hear me all right?
Everything is good. You can
Okay.
start now.
Well, thank you very much for inviting me. I'm sorry I couldn't really be in outside to give the talk in person. I was in Switzerland last week, so I was telling Dr. Lee, it's going to be difficult to make another international trip to Mexico, although to Mexico is a whole lot of closer. I have been to Mexico twice. So the first time, of course, I went to Cancun. So after my trip to Cancun, I came back to, at that time I was in Texas. I was talking to one of my colleagues growing up in Mexico, Dr. Eric Moreno. I told him I went to Mexico, and he said, where did you go? I said, I went to Cancun. And then he said, did you only stay in the U.S., the tourist side of Cancun, or you went out? I said, no, I only stayed on the tourist side of Cancun. And Eric said, no, you didn't go to Mexico. You only go to the tourist side of Cancun. That doesn't really represent Mexico. It's very different from the rest of Mexico. So the second time is when Dr. Lee was the general chair for IEEE CASE 2022 in Mexico City. I went to Mexico City that was a real experience, which I was able to appreciate more of the Mexican cultural and language, even I don't really speak Spanish. So hopefully there's another opportunity, I can go back and enjoy the hospitality of Mexican host. So today, my talk, is centered around the book I published 6 years ago, 2019, Data Science and Wind Energy. But before I get to started, because I'm serving as the editor-in-chief of INFORM's Journal of Data Science, I always do one slide to promote the journal. So the INFORM Journal of Data Science, IJDS, is a relatively new journal in the family of INFORM's publication family, and INFORM has 17 journals altogether, so this is the latest edition. It's relatively new. On the other hand, we promise of course we cannot promise accept every submission, we only can promise we do a good job reviewing the paper and in a timely manner, right? We promise a quality review on time. And what do we mean by that, right? Right now, the average review time for us is about a little bit over a month. The 90% of the paper reviewed within 75 days, okay? So hopefully that is to the liking of the authors. And even by the end of the review process, you may not necessarily agree with the decision the editor gave you. Hopefully, by reading the editor's report, the review report, you will agree the review team actually spent the time and paid attention to what you did in the paper. And that way you find the whole experience constructive, right? The journal is running a number of special issues, and we just closed the submission for the GenAI special issue, but we do have another 3 special issues ongoing, and they all have deadlines in 2026. Digital twin special issue deadline in January 2026, and then there's a AI energy special issue in May, and also AI special issue for healthcare in September. So I hope you will consider submitting some of the papers to the IJDS special issue. Okay? So back to my technical talk. So I published this book, 2019 CRC Press book on data science for wind energy. And the beginning of the book, when I was writing the preface, I quoted John Fox, who was saying, all models are wrong, but some are useful, right? I think that's a very important thing to me, because as an engineer, I was trained as an engineer. It's more kind of engineering data scientist. And I think it's very important we make what we do more relevant to the general practice, right? So that is if you have the time and read some of the chapters of the book, and hopefully that comes across one of the features to you. And by doing that, when I was publishing the book, I also gathered the data and collected the computer code use the book. We make it an open access, so it's a free use as long as you give the credit for where the data and the computer code come from, right? And so far we released 1 gigabyte wind turbine operational data. Half of them related to the book, and half of them is an extension data set that we released after the publication of the book. I have one more slide about that at the very end of the talk. Right, so the book actually was organized in 3 parts under one overarching formulation. The formulation is pretty simple at the very top of the slide, and it basically said, whatever the response you need to measure on the wind turbine, right? Be it the power production, or the stress or the mechanical load on the wind turbine, impacting the reliability part of the device, and they can be expressed as a probability response, and then further expressed as the integration with conditional response and also the probability of that wind field. So the X is the input, the environmental input, primarily the wind condition, right? So study the probability of X is about modeling the wind field and can be used for forecasting. The data science problem need to be resolved very much kind of in the category of spatial temporal analysis. In the middle part of this probability, the conditional probability, condition on what kind of X you are given, and now what kind of response you're getting out from the wind turbine device. This is really related to if the response R is what we call Y as a power response. This is really related to the so-called performance analysis, right? Given this much wind, how much power you can produce. And the data science problem is very much related to non-parametric regression, conditional density estimation, and so forth. But if the R is related to the mechanical load, and this whole formulation and the conditional response will just produce an outcome or conclusion to please them, right? So they want to know, whether or not you're overfeeding your data. You just kind of manipulate it in a way, and you want them to hear the conclusion. So of course, they don't really know exactly what is the true upgrade effect for their turbines. And like I said, they cannot do physical experiments, but they can do other things to test us. So what they did in that particular blind study is they give us 3 wind turbine data. And then in one of the turbines, they made an actually technical change to that turbine. They believe that technical change will lead to some of the difference. But they didn't really tell us, before they gave the data to us, they didn't really tell us how many turbines they made that technical change. Of course, they didn't really tell us which turbine they made that technical change. They asked us to tell them how many turbines gone through a technical change. And if there's a non-zero version of that answer, and ask us to tell them which turbine has been changed. Okay? So they give us 3 data set. Of course, the answer, there's 4 possible answers, right? 0 is also answer. Even they said they made a change, it could be they didn't really make any change to any of the turbine, right? So it's 0, 1, 2, 3. And also we need to tell them which turbines has gone through that change. So after done an analysis, we were able to identify one single turbine has been gone through that change, and we tell them specifically which turbine that was. And it turns out our answer was correct. Okay, so that was a huge relief to me. I was pretty nervous in that 1 month period when we were doing the blind study, because I cannot really be 100% certain we were right. Okay, and that really opened the door and earned that trust with the wind professionals, and afterwards we did multiple other studies with Smart Blade is a small company in Germany, and the EDPR, this headquarters in Madrid, and Goldwind in China. That's for different kind of issues, but very similar analysis. And then later on with Viken, Wind Energy Institute of Canada, we're still working with Viken now. If it's not because of the U.S.-China the policy, we probably will still be working with Goldwind in China as well. Okay, so last 2 slides is really, for the data science of AI for wind energy, one of the big issues is where do you find the data, right? If you don't have the data, how are you going to do the analysis? So we thought about that, I decided to release the data we use in the book. So on the left column is the 10 data set used the book. And then after that 2019, we published the book, we continue to release the data whenever we possible, right? The latest release is the generated failure data set, and we worked with the Viken. They are very generous, allow us to release that data. And some of the data is pretty unique. I don't really think you're going to find this kind of data elsewhere, right? For example, the turbine terrain data, associated with the publication of the IEEE transaction on sustainable energy. I think that's probably the only data set you have both of the terrain information and also the wind operation information, the wind power production information in one single data set. So it's I invite you to give it a try and to see, what you can. I'm sure you can do great things with those data. Okay. And I also sit on the IEC Wind Task Force 43 on digitalization. As one of the effort I led that Wind Task effort for collecting the open data source in the catalog. So we put that on one of the IEC Task Force website, which we don't really own the data, but we get one single stop where you can go through all the data, and most of the data they are open access, and of course the DSWE data set is among this list of data, but it is a much richer data set of that, and you can take advantage of. So with that, I will stop here, and if I can answer some questions, I'd be pleased to. There's some references. I will send the slides to Dr. Lee afterwards, and she can distribute to the conference workshop attendees.
I'm here. I'm here. Thank you so much, Dr. Dean.
Thank you.
No? No? Thank you so much. Can you hear? Thank you so much, Dr. Lee.
Yes.
You hear now?
Thank you.
Thank you so much for the so intensive knowledge and information for us. I think we need to replay this video to learn a lot, especially to get download your package and the data science, because we also do focusing wind energy. So let me ask the public if they have any questions. So can you hear? No?
I cannot hear. I cannot hear the last sentence very clear.
You cannot? Valente? Pregunta, Valente. Algunas preguntas sobre la plática.
Can you hear me?
Yeah.
I have a question about the environmental variables. How many environmental variables did you use, and how did you select to make the univariate?
So there's it really depends on how many measurements you have on the field, right? So there's a very common measurement of the wind speed, wind direction, temperature, pressure. There's a different kind of measurement about the so-called wind stability, like the turbulence intensity, like the wind shear, which is a vertical. You can also measure in horizontal. Sometimes, well, most commonly measure on the vertical ones. In the book, we share multiple data sets. Generally, they have either from 5 to 7 this kind of environmental measurement. Right? Sometimes you can have more. You can create one of the variables which may not necessarily be the raw measurement. So we typically don't really down select. We use whatever we could possibly have, right? And then we use the machine learning model. Like we said, there's 3 different components. The first one is which variable is more relevant. So that model, power curve model itself, trying to answer that question, right? So when you start with, you use all of them, and then you try to select which one is really most relevant. Sometimes, when we did the analysis, we realized the wind speed is always there, because the physics really make sure the wind speed has to be there. So the temperature almost always there, right? And the wind direction most of the time also there. The other variables come and goes. Okay, sometimes a certain kind of variable is significant in other data. Wind farm, other data sets, they are not shown as significant. So those kind of things need to be adaptively selected based on the circumstance. Right?
And for example, in the power curve, how many turbines do you use to predict? Or just one turbine and one power curve? Or how many?
So a power curve usually associated with a specific turbine. It's called a turbine specific. If you use, for example, if you have 2 wind turbines, right? You use one, either you use the 2 wind turbine data put together to generate one power curve to use for both turbines, or you use one of the turbine create one of the power curve for use for both turbines. This is considered as less ideal than you use for individual turbine, because they have different kind of environmental surrounding. The turbine, even they of the same make or same model, after a number of years of operation, they are not exactly the same anymore. So they have some unique characteristics, which is really to that particular turbine. So the best practice, as long as you could, sometimes you couldn't, as long as you could, use a turbine-specific power curve. If you have 100 turbines in the wind farm, create 100 power curves. Each power curve for one single turbine. Yeah.
Thank you.
Any more questions? So, can
Hello, Dr. Field. Thank you very much for your nice conference. I'm curious about, is there any effect of rain on the actual results of power in wind turbines? If any, then do you have to include any feature in your non-parametric model in order to take into account the effect of rain?
I'm sorry, I couldn't hear the question. The voice is a bit.
I wonder about the effect of
Question for me?
shower on the actual power results of power in wind turbines. Is there any effect of rain? If so, do you have to include any feature in your models to take into account for the effect of rain? Question.
Okay, I try to understand. You said I heard the power, and you said if there's any something I didn't capture, and then I heard about feature. So
he asked about, can you hear me?
yeah, to some extent.
He wants to know, do you consider when it rains, how do you model?
You ask when is what?
Rain, 下雨.
when it's raining.
Uh-huh.
Okay, and now what is the question?
Do you think about the raining reason or raining factor in your models?
Oh, I see. Right, yeah, so there's a two part on that, right? Number one, when it's raining, it does have certain kind of effect, right? We have actually, so through our analysis, we find the humidity, even in original physical analysis, the humidity is not part of the power production function. It only air density. But from the data-driven analysis, we find sometimes humidity can play important role in the power production efficiency. Okay, and this, when we discovered that, actually was quite a surprise to people doing the wind production research. But we actually documented in the paper we published in 2015 the humidity. So when it's raining, the humidity obviously is different when it's not raining, right? So that is a big part of that difference. And the raining has another effect. So when a turbine is operating, there's accumulated dust. And also there's insects smash on the wind blade. And when the insects smash on the wind blade, the debris don't really kind of take off. So when it's raining, actually it will wash off those kind of things from the blade. We make the blade, the air dynamic foil, and to be cleaner and to be consistent, more consistent with the original design. So people sometimes do observe there's a difference after the rain and versus before the rain, right? So those are really kind of the effect after you use this kind of method, you can detect and how much it benefit. Some of the things was not really affected by the raining. I remember there was an experience I was in discussion with one of the company. They actually told us there's a service company come to propose to do power wash for the blade because of the debris and other things. This is one particular wind farm very close to a mining operation. So they have some kind of very dirty dust accumulated on the wind blade and change the air dynamic foil of the wind blade. And the rain doesn't really kind of clean things. And so even after the rain, the wind turbine blade remain as inefficient as before the rain. So they said, we want to do a power wash and to get rid of all of the dirt from the blade, and therefore you can make your wind turbine produce more power with higher efficiency. And of course the question is, the power wash is going to cost you. So how much you're willing to pay depends on how much more power you're going to produce after the service. So it's a long question, right? So like I said, the rain doesn't affect the power production issue, and also it has some other effect which may not necessarily come into the physical, the data aspect of that. It only can be detected after the rain happens.
Thank you very much, Dr. Lee. Due to the time, we cannot make more questions. So I hope someday we could have you here physically in this auditorium, and we could have more space and time to interact with you about the wind energy and data science. Thank you so much. Let's show you the certificate. So can you? Thank you so much. So take time to have a rest for your long journey from Zurich. Okay, see you next time.
I will be there in person next time.
Sure. Just let me know. Okay.
Enjoy the rest of the conference.
Thank you so much. Bye-bye.
Bye-bye.